Next is mirrors. Mirror are the devices which are silvered at one surface and other surface is a reflecting surface. One of the type of the mirror is plane mirror, on which plane surface is silvered at one side and the other side is the reflecting surface. Concave mirror and convex mirror. This concave mirror and convex mirror are the spherical mirror. That means these two mirrors are the part of the spherical shell and the one side of the glass surface is silvered, so other side is the reflecting surface. Now first we take the plane mirror and in which we will discuss the image formation of a point object. Suppose a mirror is given, it is a plane mirror M and an object is O. For image formation we have to take two rays. Suppose one ray is incident along the normal, so angle of incidence is 0, and for normal incidence reflected ray is also along normal. Similarly, if we take another ray which is strike at the mirror at an angle say theta, this is the incident ray number 2, then it also reflected in the same media with same angle of incidence theta. Now for image formation, we backward trace the incident ray because these two rays are divergent. Therefore, on back tracing, we will get a point of intersection which will be the image of the eye. This O is the real object. So, for real object, we will have the virtual image. In this figure, if we make this point of as the N, then we now compare the triangle O and M and triangle I and M. Here the angle of incidence at M is theta and at O, because this is the alternate angle, so this angle is also theta. And at M, angle of reflection is theta, so corresponding angle is also theta. Therefore, in comparing these two triangles, we will see that angle M N O equal to pi by 2 because it is a normal, and angle M and I is also pi by 2. So these two angles are equal. Similarly, another angle which is angle OMN, that is equal to pi by 2 minus theta. This angle is pi by 2 minus theta. And similarly, triangle IMN, this will be also pi by 2 minus theta because this angle is theta, pi by 2 it is theta, so this angle is pi by 2 minus theta. Therefore, these two angles are equal and their corresponding side, that means the side which included by these two angles, which is MN, in both cases is MN. Therefore, we can say triangle O and M is congruent to triangle OI and M. Hence, we can say ON equal to IN. That is, the distance of the object from the mirror is same as the distance of the image from the mirror. Here are some notes. Point of intersection of incident rays forms the object, and point of intersection reflected rays gives image. Second point is object and image may be real or virtual. Virtual are those which cannot be taken on the screen, while the real are can be taken on the screen. Third point is for real object, image formed by plane mirror will be virtual, and for virtual object, image formed by the plane mirror will be real. Next is the image formation of the extended object by the plane mirror. Suppose a plane mirror M is given and an object AB. For image formation, we take two rays from the point B. Say one is along the normal to the mirror. This is the first incident ray. So after reflection, it returns along the normal. Similarly, another ray strikes at the point O and at an angle alpha. So it angle of reflection will also equal to alpha, and it returns along the point N. Now if for image formation, we extend these two reflected rays backward and we get a point of intersection, say B dash, and from B dash we drop a normal. This will give the image of the point A. So A dash is the image of point A, B dash is the image of point B, and A dash B dash is the image of the object AB. From geometry we can easily prove that A dash B dash will be equal to AB, that is the size of image will equal to the size of object. Similarly, distance of image from mirror, that is a plane mirror, will be equal to the distance of object from the plane mirror. Also, third property is that image is laterally inverted. Let's take a problem. What should be the minimum height of a mirror to enable a man of height h to see his full image? Suppose this is the mirror which height is required and it is AB, and there is a man which height is given h. The top point is head for the man and it is the foot, and the normal from point A and B are suppose C and D. Now we take a ray incident at point A at an angle suppose alpha 1, then reflected ray is also at an angle of reflection alpha 1 and meet at a point E, which is the eye of the man. And critically, the foot also has an image at the point E, that is at eyes. This ray incident at angle of alpha 2 and angle of reflection is alpha 2. Now from the figure we can see that AB, which is the height of the mirror, that will be equal to CD, and this CD will be equal to CE plus ED. This CE is the midpoint of HE because the angle made by the perpendicular at the C from A makes angle alpha 1. Therefore, we can say that CE will be equal to half of EH, and ED equal to half of EF. So we can write it is half of EH plus half of EF, or it is equal to half of EH plus EF. And EH plus EF is the total height of the man, that is H. So we can say height of mirror, that is minimum height of mirror to see the complete image of the man, will be equal to half of the height of the man. Restriction in this problem is that the top edge of the mirror, that is A, must be horizontal level halfway between the head and the eye. Then it will give the this limiting case of the minimum height of mirror, that is equal to half of the height of man.